Today we'll be talking about solving integrals using u substitution. We use u substitution so we are able to rewrite the problem to match one of the general rules. For this first example, we will be explaining how to use u substitution. The first thing we need to do is make the problem look like one of the general rules. To do this, you will need to decide what u will be. U is usually exponents, what is in the parentheses, or the numerator or denominator of a fraction. For this example, u will be equal to 2x. You can then rewrite the integral as the integral of sine of u dx. Now we have it in the same form as the general rule. Next we have to make the integral in terms of u. To do this, you have to make dx equal to du. So you will need to take the derivative of u. You will then get du equals 2 dx. You will need to get dx by itself, so you will divide both sides by 2. You will then get 1/2 du equals dx. We will then need to rewrite the integral in terms of du. This will look like the integral of sine of u times 1/2 du. You can then move the 1/2 to the outside, getting 1/2 times the integral of sine of u du. You will then take the integral like any other integral. You will end up with 1/2 times negative cosine of u plus c. You will then have to fill in the u. Your final answer will be negative 1/2 cosine of 2x plus c. For this next example, you will have a square root in the problem. This isn't much different from the first example, except you will be making u equal to what is in the square root. So u will equal x cubed plus 1. You can then rewrite this as the integral of x squared times the square root of u dx. Then you will have to take the derivative of u. You will get du equals 3x squared dx. You will then divide by 3 on each side. You will get 1/3 du equals x squared dx. You will then notice that the x squared and the dx are in the original integral. That way you can sub du in for both. So then you will get 1/3, because it can be brought out, times the integral of square root of u du. You will then refer back to this regular rule to take the derivative of the square root of u. The square root of u equals u to the 1/2. So you will add 1 and then divide by n plus 1, which is 3/2. So finally, you will get 1/3 times 2/3 u to the 3/2 plus c. You will then plug in u, and your final answer will be 2/9 times x cubed plus 1 to the 3/2 plus c. Let's do another example. In this example, we will be solving an integral that has an exponent in it. We will be making u equal to the exponent. So u will equal negative x over 3. You will then write this as the integral of e to the u dx. Next, we will take the derivative of u. you will get du equals negative 1/3 dx. Then you will multiply both sides by negative 3 to get dx by itself. You will get negative 3 du equals dx. Next, we have to make the integral in terms of u. This will look like negative 3 times the integral of e to the u du. Then you will refer back to the general rule of the integral of e to the x dx to take the integral. You will then get negative 3 times e to the u plus c. You will then plug in u, so your final answer will be negative 3 times e to the negative x divided by 3 plus c. In this next example, we will be solving an integral that has a fraction with an exponent as the numerator. It'll be a little harder to figure out what u is because, as we said before, it can be what's in the parentheses or numerator or denominator. For this integral, u will be equal to what's in the parentheses. So u will be equal to ln of x. The integral can then be written as the integral of u cubed divided by x dx. Next, we have to make the integral in terms of u. To do this, you have to make dx equal du. So you will need to take the derivative of u. This will get you du equals 1 over x dx. You may think you're stuck, but if you look at the integral, you may realize that you can rewrite the integral as u cubed times 1 over x dx. You then realize that these two parts match and it's your du. So then you can rewrite it as the integral of u cubed du. You will then take the integral using this general rule and get 1/4 times u to the 4th plus c. You will then plug in u for your final answer and get 1/4 times ln of x to the 4th plus c. Now let's try one more example. In this last example, we will be solving an integral that is in a fraction. To do this, we will need to decide if the numerator or denominator will be equal to u. First, we will try making u equal to the numerator, so u will equal x. We will then take the derivative and get du equals dx. As you can see, this doesn't knock the bottom out for us, so u cannot be equal to x. Now we will try making u equal to the denominator. So u will equal x squared minus 4. We will then take the derivative and get du equals 2x dx. We can then divide both sides by 2 and get 1/2 du equals x dx. Then we can rewrite the integral as the integral 1 over u x dx. You can see that our du is equal to the x dx, so then when you finally rewrite this integral, you will get 1/2 times the integral of 1 over u du. You can then refer to the general rule and solve the integral. You will then get 1/2 times the ln of u plus c, and then you'll have to fill in the u. So your final answer will be 1/2 times ln of x squared minus 4 plus c. To summarize this, we use substitution to solve an integral when the problem doesn't match one of the general rules. Substitution makes it possible to rewrite the problem to match a general rule. I hope this was helpful.